Hello and welcome to episode 13 of Cloud Tech 10 for the 5th of June 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. Draft is an open source project designed to make it easier for developers working with Kubernetes to streamline their development process. I'm going to show you how you can use Draft with the Azure Container Service and Azure Container Registry. Draft has 4 dependencies that we'll set up in Azure. It needs a container registry, a cloud-based Kubernetes cluster, Helm, and an ingress controller for Kubernetes. The easiest way to get up and running with the Azure Container Service is with the Azure CLI, and the easiest way to get the Azure CLI is via the Azure Cloud Shell. So let's open one up from the Azure portal. So first I'll create a resource group to keep all of this together in one place. I just need to name the resource group and choose the Azure region it will be created in. We're going to use the Azure Container Registry as a private repository for the Docker containers that Draft will create for us. So I'll create a new container registry. I just give it a name and specify the resource group that the registry will reside in. Okay, let's create an instance of the Azure Container Service using Kubernetes as the orchestrator. I give the container service a name, a DNS name prefix that will be used to form the URL for cluster resources, and the resource group I want to deploy this to. The generate SSH keys option will automatically create SSH keys and configure the resources to use them. And I specify that I want to use Kubernetes as my orchestrator. With that done, I now need to install the Kubernetes command line tool, but the Azure Cloud Shell has a bunch of popular tools pre-installed. So if I type kubectl, I'll see that it's already installed. I will need to set up the credentials that kubectl will use to connect to my new Kubernetes cluster. The Azure CLI can help me with that too. I use the ACS Kubernetes get credentials command and provide the name of my resource group and ACS cluster. If I look in my Cloud Shell's file system, I'll see that I now have a hidden kube folder. This contains the configuration details that will allow kubectl to connect to my cluster. And because Cloud Shell persists my profile across sessions, this configuration information will still be there whenever I launch a new Cloud Shell. So now I can use a command like kubectl get nodes, and I'll see I have 3 nodes and 1 master. The next dependency to install for Draft is Helm. I'll use curl to download the latest version, then unpack the downloaded file, and because I'm in the Azure Cloud Shell, I'm going to put the files into a folder in my profile, so that, as before, this will be available to me in future Cloud Shell sessions. I've already modified my path so that Draft and Helm are included, so next we get Helm set up, which is really simple. Just type in Helm init, and that's it. This will set up both the client and the server side of Helm. And if I take a look at the Kubernetes UI, I'll see that Helm's server-side tiller service has been deployed. Now let's set up the final dependency, an ingress controller for Kubernetes. Ingress provides a way to route traffic from the internet to services within a Kubernetes cluster. An Nginx-based ingress controller is available via Helm, so let's install that. And then we wait for a load balancer to be created. We just need to wait for the external IP to be populated with an external IP address. So Draft uses a wildcard domain to make accessing Draft-created applications easier. So I need to set up a DNS entry pointing to the IP address that's just been configured. So we have all of our dependencies in place. Now we just need to set up Draft itself. We'll download Draft, unpack the files, and as we did with Helm, let's place them somewhere persistent. Draft needs to know the URL and credentials for our Azure Container Registry instance. We can get the credentials from the Azure portal or from the Azure CLI. We need to place the credentials into this format. The username and password come from the credentials we just obtained, and I just add my email address at the end. And then we base64 encode this. Now let's get Draft set up. We run Draft init and provide the URL for our Azure Container Registry instance, the base64 encoded credentials, and the wildcard DNS domain. Now, that is the server-side setup complete. The whole point of Draft is to streamline the developer experience when working with Kubernetes. So, step aside ServerMonkey, let's let the developer do their thing. I'm working from a Linux server now. Actually, I'm working from a Bash on Windows session on Windows 10, but it will work just as well. There are a few dependencies to set up on the server side, but for the client, it's much simpler. I need to have connectivity to my Kubernetes cluster, which I've already set up, and as with the server installation, I'll need to download and unpack the Draft files. So, download, unpack, and place them where they can be found, and initialize Draft. To make things simple, I'm going to use the examples in the Draft GitHub repo. So I'm going to run git clone, and then in the examples directory, we have a choice. Let's go with Node.js. So in here, you can see we've got a very simple Node.js application. Let's get this into our Kubernetes cluster now. First, we run Draft create, and you'll see that Draft creates this as a Node.js application. Now we just run Draft up. Draft is now running through the process of creating a Docker container for our Node.js application, including downloading a Node.js image and running npm. When it's finished, it will push the container to the Azure Container Registry. Once that's complete, the container will be deployed to our Kubernetes cluster. So this oddly named URL has been auto-generated, which means that everything is now deployed and ready to use. If I look in the Azure Container Registry, I can see the container that's been created. If I look in the Kubernetes UI under deployments, I can see that my app has been deployed to 2 pods, and under pods, I can see those 2 pods and can drill down to view more details about each pod. And if I hit that odd looking URL, there's my app. But wait, that's not all. Let's just quickly flip back to my Bash command command line. You'll see that draft is still running and says that it's watching local files for changes. Aside from making it easier to deploy an application to a Kubernetes cluster, draft also makes it easy for a developer to update that cluster as they continue working on their code. Let's go to another command line instance and make a small change to the index.js file of our Node.js application. Now I'm going to save this file and very quickly switch back to the other command line. And you can see that draft has spotted that the file has changed and has set about updating the containers and updating the Kubernetes cluster. From the Kubernetes UI, we can see the update in progress, and once it's finished, if I refresh the browser, here's my freshly updated Node.js application. Disaster recovery for Azure Iaas virtual machines is now available in public preview. This feature uses Azure Site Recovery to allow you to replicate Iaas-based applications to a different Azure region. I've got 2 Iaas web servers running in the West Europe region as part of an availability set. I'll set up disaster recovery for these servers in the North Europe region. To configure disaster recovery for my virtual machines, I click on Replicate. I now have the choice of on-premises or Azure as the source for replication. West Europe will be the source Azure region, and I want to select virtual machines that are in this resource group. The 2 web servers I have deployed in that resource group are shown. To replicate them, I just need to select both of them. I have options to configure how the target site will be set up, including the target resource groups, virtual networks, storage, and availability sets. By default, the recovery point retention is set to 24 hours, and app consistent snapshots are taken every 4 hours. I can customize these settings if required. I click on Create Target Resources, which will establish the resource group, networks, storage, and availability sets, and then enable replication. Initial replication is now taking place. I can track the progress in the Replicated Items tab, and after a short while, I should see that both servers have replicated successfully and are now protected. I can test the failover for an individual virtual machine from here. I just need to select the recovery point and the virtual network I want to use. I can monitor the test failover progress and see detailed status and results here. In this scenario, my virtual machines are part of an availability set, so really I want to test the failover of both of these together. I can create a recovery plan which includes both of my servers. Once that's done, I can test the failover of the recovery plan, wait for the test to complete, and view the status. Azure SQL Database standard elastic pools now feature higher eDTU limits. Previously, the maximum eDTUs per database for standard pools was limited to 100. With this public preview, that limit is now 3000 eDTUs. As well as the new higher limit, there are also new stops at 200, 300, 400, 800, 1200, 1600, 2000, and 2500 eDTUs. In the March 20th edition of Cloud Tech 10, I demonstrated the use of Azure Batch with the Do Azure Parallel R package, which allows jobs written in R to take advantage of Azure Batch's ability to automatically scale and distribute workloads over multiple nodes, and showed how a job which took 15 minutes to complete on a single server completed in 3 minutes using Azure Batch. The Do Azure Parallel package has now been updated with support for Azure Batch's new low priority VMs, which I covered in the 15th of May edition of Cloud Tech 10. Combining these 2 features means that our users not only get improved performance and reduced compute times, but now they can also take advantage of the cost savings provided by using low priority VMs. As well as low priority VM support, Do Azure Parallel has also been updated to work with Carrot and Playa, job management and monitoring for long running R jobs, support for resource files to preload data, and help for reading and writing to Azure Blob Storage. 2TB and 4TB disk sizes are now available for premium and standard managed and unmanaged disks. At present, this support is provided through the command line tools and Azure Resource Manager, and only available in the West Central US region. However, support for the Azure Portal and other Azure regions will roll out over the coming weeks. To create a large disk using the Azure CLI, you can simply use the AZ disk create command, specifying the size in gigabytes of the disk that you want to create. You can then attach the disk to a virtual machine using the AZ VM disk attach command. Once that's complete, you can verify in the portal that the virtual machine now has a 4TB data disk attached. At Build 2017, the Azure Portal App and the Azure Cloud Shell were both announced. Last week, the Azure Portal App was updated and now includes the Azure Cloud Shell. This means you can now get access to a command line environment pre-configured with the Azure CLI and a bunch of other useful tools from a mobile device. Earlier on in this video, I showed how to set up draft using the Azure CLI. I also mentioned that the Azure Cloud Shell provides persistent storage. So if I do an ls in the shell, I'll see the draft, Helm, and Kubernetes related folders that were created during that demo. So that means I've got access to the same tools. I can run kubectl and check out the status of my pods in Azure Container Service. Plus, I've got the Azure CLI and many other tools, allowing me full control of my Azure environment from a phone or tablet device. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share and subscribe, or follow me on Twitter. I'll see you next week. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe, and follow me on Twitter for more.